All right, welcome back. Today, we're jumping right into a single technique from Vedic mathematics that is so powerful, it can handle literally any multiplication problem you can think of. So, let's get right to it.
Okay, so you've gotten really good with the Nicola method, right? It's amazing for numbers that are close to a base, like 100. But what do you do when you get a problem like, say, 41 times 32? I mean, neither of those numbers is anywhere near a convenient base. Nicola just isn't the right tool for the job. So what then? Is there some kind of universal method?
Well, you bet there is. Vedic mathematics has this one single, really elegant technique that works for all of them, any multiplication problem. And here's the thing. It's not just that it's universal. It's often way faster than the methods you learned in school, and it's absolutely perfect for doing math in your head.
And believe it or not, the entire method is packed into this one single beautiful sutra. Now, I'm going to do my best to pronounce this correctly. UrdhwaTiryak. Yeah, I know. It looks a little intimidating, right? But the meaning behind it is surprisingly simple. And trust me, it's the key to this whole thing.
So what does that big fancy word mean? It just means vertically and crosswise. That's it. That's the entire instruction manual in 2 words. And what's really cool is that it's a method that works from left to right, which, if you think about it, is fantastic. You get the most important digits of your answer first.
All right, enough talk. Let's actually see this vertically and crosswise thing in action. We'll start with a nice, simple example to get our feet wet. 12 times 13.
Okay, so first up, we follow the instruction vertically, but on the left side. So we look at the leftmost digits of both numbers. That's a 1 and a 1. Multiply them together. 1 times 1 is, well, 1. That's the first part of our answer. Easy enough, right? Now for the next part, the crosswise instruction. This is where the magic happens. We're going to multiply the digits diagonally and then add them up. So you take the 1 times the 3, that's 3. Then you take the other diagonal, the 1 times the 2, that's 2. Now just add those 2 results together. 3 plus 2 gives us 5. And boom, that's the middle part of our answer.
And to finish it off, we go back to vertically. But this time, we do it on the right side. We just multiply the rightmost digits. That's 2 times 3, which equals 6. And that's it. That's the last part of our answer.
So now, all we have to do is put the pieces together. We just line them up. We had a 1, then a 5, then a 6. The answer is 156. See that? No complicated carrying, no writing multiple rows of numbers and adding them up, just 3 quick, simple steps.
Okay, I know what you're thinking. That was pretty neat for small numbers, sure. But what happens when the pieces you calculate are bigger than 9? What do you do when you actually have to carry a number over? Well, this is where the method really starts to show off its true power.
Let's crank up the difficulty a little bit. We're going to try 37 multiplied by 33. This time, we're definitely going to see some numbers that need carrying over. We're going to follow the exact same pattern. So vertically on the left, 3 times 3 is 9. Got it. Crosswise, that's 3 times 3 plus 3 times 7. So 9 plus 21, which gives us 30 for the middle part. And finally, vertically on the right, 7 times 3 is 21. So our raw uncarried result is this little chain of numbers 9, 30, and 21. Okay, so how do we handle this? Let's walk through it. We always start from the right. Our rightmost part is 21. So you keep the 1 and you carry the 2 over to the left. That middle part was 30, right? So we add the 2 we carried. 30 plus 2 is 32. Now we do the same thing. Keep the 2 and carry the 3 over to the next part on the left. Our leftmost part was 9. We add the 3 we just carried, and 9 plus 3 is 12. So now let's read off our final digits. We have the 12, then the 2, then the 1. The answer is 1,221.
You know what's just amazing about this is that the vertically and crosswise pattern scales up perfectly. It's not just for 2-digit numbers. It works for 3-digit, 4-digit, any size. So let's see just how powerful this gets when we try a 3-digit multiplication.
So for a 3x3 problem, the pattern just expands. It becomes a 5-step process, and it's beautifully symmetrical. You go vertical on the far left, then a small crosswise, then a big crosswise using all the digits,
then another small crosswise, and finally, vertical on the far right. It's like it expands out and then contracts back in. Really cool.
Okay, let's put it to the test with 116 times 114. Ready? Step 1, vertical left. 1 times 1 is 1. Step 2, the first crosswise. 1 times 1 plus 1 times 1 is 2. Step 3, the big one, the star pattern in the middle. 1 times 4 plus 1 times 6 plus 1 times 1. That gives us 11. Step 4, the crosswise on the right side. 1 times 4 plus 1 times 6 is 10. And finally, step 5, vertical on the far right. 6 times 4 is 24. Phew! So our raw result is this 5-part chain. 1, 2, 11, 10, and 24.
And when we apply that same carrying logic we just learned, starting from the right and carrying over, that big, messy chain of numbers just elegantly resolves into one clean answer, 13,224. The process is exactly the same. It doesn't matter how big the numbers get.
I mean, once you get the hang of this, it is so fast and efficient. But you have to be wondering, right? Is this just some clever trick, a bit of mathematical magic, or is there something deeper, something really fundamental happening here?
And the answer is no. It's not magic. Not at all. What you're actually doing is taking a brilliant visual shortcut for algebra. Yep, the UrdhwaTiryak method is algebra in disguise. And here's the proof, plain and simple. Look at this. On the left, you've got the standard way you'd multiply two binomials in algebra class. And on the right, that's the UrdhwaTiryak pattern we just used for our two-digit numbers. Just look at them. The components, the pieces, they're exactly the same.
Let's just spell it out. That AC term from the algebra, that's our first vertical multiplication. The AD plus BC part in the middle, that is exactly what we calculate in our crosswise step. And the DD term at the end, that's our final vertical multiplication on the right. It's a perfect one-to-one match, no coincidence.
So here's the crucial point. Every single time you use this method, you are actually doing algebra. You're performing algebraic expansion. You just don't realize it because you're using this amazing, structured, visual process that gets rid of all the complicated notation and just leaves you with the simple arithmetic. And that is the real genius of this sutra. It's not a trick. It's a fundamental principle, a whole new way of organizing calculations. It completely reframes how you can look at numbers, and it turns something that seems complicated, like algebra, into a simple, beautiful, repeatable pattern. And it really makes you wonder, doesn't it? What other problems, maybe even problems outside of math, could be solved or at least simplified if we just learn to look at them vertically and crosswise?